Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is Exploration. Every week on Exploration, we discuss the fascinating world of science and its impact on society. And today, we're going to summarize some of the top stories in science. Our lead story is perhaps one of the strangest stories to come across our desk in, well, maybe decades. First of all, people have always looked for signs, any kind of sign of intelligent life in the universe. Some people look for flying saucers. Some people look for, well, alien crash flying saucers and little dead aliens. However, astronomers look for some kind of structure in outer space that could only be artificial. Well, this news story has now created a frenzy on the internet. In fact, if it's correct, and we don't know if it is correct or not, it could be the biggest story since the discovery of fire or the invention of the wheel. And that is an alien megastructure that's perhaps even bigger than Jupiter may have been sighted by the Kepler telescope. Let me explain. First of all, the Kepler telescope has been orbiting in outer space for quite a while, for several years, and it's detected over 1,000 planets circulating other stars in deep space. And how does the Kepler satellite do this? It looks for shadows of planets that then go right across the surface of the mother star, and starlight begins to damp as a consequence. In other words, the planet eclipses the mother star, and starlight diminishes by maybe 0.5% or 1%. Well, this is where the magic occurs. Back a few years ago, the Kepler telescope identified a star about 1,500 light years from the Earth, such that starlight dimmed not just 0.5% or 1%, but by 15%. This is humongous. This had never, ever happened before. And a few years later, it damped once again by a factor of 22%. This is unheard of. Whoever thought that starlight could diminish by that much by an object which seemed to be, well, not natural? In some sense, maybe it was artificial because it didn't seem to be shaped like a circle. Everything in outer space that we see, large objects anyway, are basically round. However, this object may not be round, and its orbit is highly irregular. Well, this sent astronomers scrambling to the blackboard, trying to figure out what the hell is this object. Well, we'll say more about this in a few more minutes when we get right into the news of the past week. As I said before, the lead story today concerns an alien megastructure. Now, let me explain. When scientists look for signals of intelligent life in outer space, they don't look for little green men. They don't look for flying saucers. They look for two things, at least. First is radio signals that obviously imply intelligence. Radio signals that are regular rather than simply being static. Second of all, they look for alien structures, megastructures. If aliens are really out there and they're advanced, they may be able to assemble an object perhaps as big as a planet. Or they might be able to play with natural phenomenon. In other words, starlight would be affected by their very presence. So far, we have found neither. I repeat, we have found neither. No evidence of any radio signals exhibiting any regularity or any message, and no alien megastructure until now. Now astronomers are scratching their head. They're wondering what the hell could be causing this. As I mentioned earlier, there's a star about 1,500 light years from the planet Earth, and starlight does indeed dim, just like the Kepler telescope has verified. That's not a big deal. However, the dimming of starlight is usually on the order of 0.5% or 1%. However, here, the starlight dimmed by a factor of 15 to 22%. This is gigantic. This is off scale. Think about it for a moment. An object bigger than Jupiter that seems to be artificial. Now, let me explain. We scientists, when we talk about civilizations in outer space, rank them by energy, type 1, type 2, or type 3. A type 1 civilization can harness planetary energy. For example, all the energy that strikes their planet from the sun. They could, for example, control the weather. A type 2 civilization harnesses the energy output of an entire star. For example, the Federation of Planets in Star Trek might be a type 2 civilization. And then there's type 3, galactic. They control the galactic space lanes. And what do we have here? We have an object that is apparently, who knows for sure, exhibiting type 2 technology, specifically a Dyson sphere. Now, what is a Dyson sphere? Freeman Dyson, physicist at Princeton, knew that there was this ranking of intelligent civilizations by energy output. And he reasoned that if there really was a type 2 civilization, its energy consumption would be so great that they would literally control the energy output of the entire star. Now, how can you do that? You could do that by building a shell around the mother star, which then absorbs all the starlight from the star. Now, you can imagine, a civilization comparable to ours cannot do such an incredible feat. We can barely create cities, let alone an object much bigger, for example, than Jupiter. So a type 2 civilization would have a signature. They would be able to play with starlight. So that light from the mother star would flicker. It would be perhaps irregular, or perhaps the star would simply disappear totally. Well, eventually, the Dyson sphere itself would heat up by the second law of thermodynamics, and it would get hot. So it would start to glow in the infrared. Well, given that fact, scientists have actually looked for type 2 civilizations in outer space. They should at least be able to radiate infrared radiation. And so scientists have taken this very seriously and looked for evidence of a type 2 civilization. What did we find? Nothing. We find no evidence of any radio emissions from intelligent species. We see no evidence of infrared planets in outer space. Well, that's why this new story is very intriguing. In 2011, the Kepler satellite first found evidence that something spectacular was happening with this star. Starlight was dimming by 22%. That is off scale. Now, as Carl Sagan once said, remarkable claims require remarkable proof. This means that you simply can't announce to the world that we found it. We have found evidence of intelligent life in outer space. No, it doesn't work that way. Scientists are cautious revolutionaries. That is, they are very cautious until they are finally convinced that what they are sitting on is earth-shattering. Then they become revolutionaries. So scientists, being conservative revolutionaries, notice this star making this tremendous change in intensity. So scientists begin to look at possible candidates. First, meteors. Well, meteors are a possibility, but they're very tiny. This object is perhaps even bigger than the planet Jupiter. So cross off meteors. What about another planet? Well, this object is even bigger than Jupiter. It would have to be huge. What about comets? Same thing applies with comets. That is, they are small objects. Well, one by one, they crossed off all possibilities until they were left with the last possibility, which is an alien structure. A structure built by a civilization perhaps thousands of years ahead of us. Now, what are we on this cosmic scale, and how long will it take for us to attain this kind of status? We are type 0 civilization. That is, we get our energy from dead plants, oil, and coal. We are nothing to brag about. Type 1 is perhaps 100 years more advanced than us. Type 2 is perhaps a few thousand years ahead of us. And Type 3 is perhaps 100,000 to maybe 1,000,000 years ahead of us. So if a civilization had the power to create some kind of sphere, some kind of solar collecting device comparable to the size of Jupiter and beyond, then we are talking about a Type 2 or a Type 3 civilization. And so scientists begin to say, oh my God, what could possibly rival the energy of a Type 2 or a Type 3 civilization? Now, there are exotic possibilities. These possibilities are extremely rare, but since we are dealing with an unprecedented phenomenon, we have to consider them. One possibility is that we have a highly irregular solar system. A solar system in which many planets can seem to coalesce in front of the mother star because of their random orbits or strange orbits, eccentric orbits around the mother star. This would help to explain why it was irregular, and also perhaps looking at the object, you would see multiple planets, and therefore starlight would dim more than just 1%. Still, it stretches the imagination to believe that you can have an object that can dim starlight by 22%. Well, another candidate is some kind of collision between comets. Maybe this object is actually quite closer to the Earth, not so far away, not orbiting right around the mother star, so it gives the impression that it's bigger than it actually is. And, as a consequence, perhaps this object is really not the size of Jupiter. Perhaps it's a comet storm, a collision of multiple comets. That is also a possibility that cannot be ruled out. Any other possibilities? Well, if you can think of one, perhaps you can have your name in lights if it turns out to be correct. In other words, we really don't know. At the present time, we are really clueless as to what natural phenomenon can account for an object that big with that particular shape and that particular characteristics. Then the next question is, what's the next step? What do you do after you find evidence that there could be an alien megastructure in outer space? The next thing to do, which wouldn't cost that much, is to focus our radio telescopes to look for any hint of intelligent life. Realize that we've been doing this, but only for a few thousand stars. Believe it or not, there are 100 billion stars in the Milky Way galaxy. And how many of them have actually been analyzed in detail? Well, you'd be shocked. Just a few thousand. A few thousand out of 100 billion stars that exist in our solar system. So we have a long ways to go before we can begin to say that we've analyzed even a significant fraction of the number of stars in the Milky Way galaxy. And what do we look for? We look for any signs of regularity. I mean, after all, the aliens don't speak English. The aliens don't use the same mathematical symbols as us. So how would we recognize a signal from an alien civilization if it were staring at us in the face? It would be regular rather than random. That is perhaps the only clue that we would have that we're literally listening in on I Love Lucy from outer space. So, any sign of regularity, any sign that is non-random, that would be the signal. And now we're going to focus our radio telescopes, instead of looking at thousands of stars in the solar system, we'll look at this particular star to see whether it has any regularity in its messages. Next, what do we do about it? Do we call them on the telephone and say, hey, here we are, brothers in the galaxy? Nope, it doesn't work that way. This star is about 1,500 light years from Earth, meaning that it would take about 1,500 years for a message to go from the Earth to this star. And once they receive the message and they send back a message from outer space, it would take another 1,500 years for us to detect it. So in other words, a two-way conversation would be basically impossible. It would take 3,000 years for a message to go from here to there and back. But perhaps the biggest criticism of this approach is, what happens if they don't use radio at all? Perhaps they view radio as archaic. I mean, for example, do we use smoke signals? Do we use smoke signals to communicate here on the planet Earth? Of course not. I mean, smoke signals are a sign of desperation when you have advanced electronics. But you have to admit that the message on a smoke signal does in fact travel at the speed of light. For example, let's say they use laser beams. If they use laser beams, they would be collimated. They would be in the optical frequencies rather than the radio frequencies. And basically, we wouldn't know. We wouldn't even know that we were staring at a message right in front of our eyes because we would not have the instruments that are focused in on the optical frequencies, that are focused in on the characteristics of laser light. And so simply looking for signs of intelligent life by analyzing its radio signals is kind of pathetic. Sorry about that. So a two-way conversation with them would be practically impossible. Then the next question is, well, if they're that advanced, that is thousands of years more advanced than our civilization, then why don't they visit us? Why don't they come in, announce their presence, and give us the benefit of their advanced technology? Well, as I've mentioned before, if you're walking down a country road and you see a bunch of ants in an anthill, are you tempted to go down to the ants and say, I bring you trinkets, I bring you beads, I give you nuclear energy, take me to your ant queen? Or do you have this politically incorrect urge to perhaps step on a few of them? Well, that's the problem. You see, we are so arrogant to believe that an alien civilization, thousands of years more advanced than us, would be dying to land on the White House lawn to announce their existence. Nope, not a good idea. And then we have the position of my colleague, Stephen Hawking, who says that why even bother to try to make contact with intelligent life in the universe, because chances are they're going to be evil. And if they're evil, the first thing they may want to do is take us over. I mean, an example he cited was the conquistadors. What did they do to the Aztec Empire? They destroyed it. They plundered the Aztec Empire. An empire that took thousands of years to rise from the forest was essentially wiped out within just a few matter of months. They could do the same thing to us. And so it's dangerous to make contact with intelligent life in outer space. So says Stephen Hawking and others. My particular point of view is that, well, we should not advertise our existence to aliens in outer space. But, hey, we've been admitting I Love Lucy of our own for the last 50 years into space. My personal attitude is that we should not go out of our way to advertise our existence in the universe. Of course, during the days of the Pioneer spacecraft, they actually put a medallion on the spacecraft giving the coordinates of the planet Earth, giving a description of life on the planet Earth, and any alien which picked up this medallion could easily triangulate and easily figure out where we are located. And then what's the alien response going to be? Well, are they going to say, lunch? Gee, lunch just occurred in the form of a Pioneer spacecraft. Let's go for lunch. Or are they going to say, these are intelligent creatures. Maybe we should make contact with them. I think more than likely, if they pick up a medallion or sense that there is life on the third planet from our sun, they would say, interesting, but so what? They have nothing to offer us. We have nothing to offer them because they cannot even begin to understand our technology. So for the most part, we would leave them alone. And then the next question is, well, if you really do have a Type 2 civilization, probably it's been probing neighborhood stars for years looking for intelligent life, what is the best way to search for intelligent life in the universe? Well, I'll be blunt. Sending Captain Kirk on the Starship Enterprise is perhaps the worst way to search for intelligent life in the universe because there's simply too many stars. You spend billions of years hopping from one star to the next, trying to analyze 100 billion stars in the Milky Way galaxy, of which perhaps 1 billion actually are Earth-like suns. So what is the best way for them? The best way for them to search for intelligent life in the universe is through robots. That is, self-replicating von Neumann probes. Probes that make copies of themselves. Starting from one probe, you could put it, let's say, on a moon, which is stable. It makes 1,000 copies of itself from moon rock. They scatter, land on 1,000 other moons, and then create each one 1,000 more probes. Well, from one, you get 1,000. Then from 1,000, you get 1 million, 1 billion, trillion, quadrillion. And then in 5 generations, just 5 generations, you get quintillion of these space probes shooting out into outer space. This means that perhaps on our moon, on our own moon, there could be evidence of a previous visitation. And that, of course, is the basis of the movie 2001.